Hi, I'm Jeff Teeter. I'm a systems engineer with the America Partners Organization, and today we're going to take a look behind the scenes of the program SDN RAN, or Darth RASP, which was is an automated disaster recovery exercises program. And specifically, we're going to look at the Raspberry Pis that are programmed to be network monitors. And we'll go ahead and take a look at the program and discuss a couple things that you might find interesting. Let me go ahead and transition to the screen so you can see what's going on. Let me go ahead and stop the program and then go ahead and actually bring up the source code here real quick. Okay, and the program is actually fairly simple. There's two components to it, and I did want to go ahead and mention for those of you that took the Coursera class and is really familiar with simple GUI, that you can transition to the program or to the modules that I use to write the graphics for the network monitor. If you go to codesculptor.org and then just hit the demos button, it will go ahead and bring up a bunch of different sample programs, and on one of the tabs there's a simple GUI to Pygame. So Pygame is the module that I use to write the graphics component, and there's some different videos. I recommend the simple GUI to Pygames that were videos that were made in 2013. They're kind of pretty simple, kind of cartoon instructions of basically how to transition from simple GUI to Pygame. So you might check that out, but let me go ahead and go back to the actual code for this program. So there's basically two parts to this. The first part is really about determining what the display is that you're going to be using and getting the buffers ready and all that kind of stuff. And I would recommend, and a lot of the source code on just getting the screen display ready is taken from this URL. So I would go ahead and take a look at that. I'll go through some of the components so you can understand it, but for a much more in-depth process, I would definitely go ahead and take a look at that. The modules that were used in this program is OS for operating system, Pygame for the graphics, using time to cause a delay using time.sleep, and then I'm using subprocess to actually basically spawn a new process, in this case ping process, and get the results and return that, and then be able to make a decision based on those results. And in this particular process or situation, what I'm doing is changing the screen color based on the results of the different pings that are going on. So the first part of the program is basically just determining what the screen display needs to be to go ahead and display it correctly. And there's a class PyScope that I got from the URL that I talked about earlier, and this is basically just getting that information, getting the buffers ready, and getting ready to display something on the screen. There's nothing that's actually happening here yet, but it's just setting everything up and getting everything initialized and ready to go. So the first thing that happens when the program runs is it displays a Pi logo, and what we're going to do here is we're calling the class PyScope. We have an image that's already actually loaded in the same directory, which is the Raspberry Pi logo. We go ahead and tell it that we want the screen to be white, which is the 255, 255, 255, and you can change those, of course. It's the red, green, and blue attributes. And then we give it the X and Y coordinates here where we want the logo to be displayed. And then with Pygame, this is all being done kind of in the background, which is what makes Pygame so attractive. Is it goes ahead and gets that rendered, and then once it's ready, you can go ahead and tell it to display it, and it basically flips that. And that way, if you're doing lots of graphics, it's very smooth because the image is already rendered really from a compute standpoint before it's actually displayed. So we go ahead and display the Pi logo, and then we just have a command in here to go ahead and have a pause for 15 seconds, and that's kind of rough. Sometimes it's a little bit less than that, sometimes a little bit more, but for the most part it's fairly close. And then we go ahead and do basically the same thing. Is we go ahead and render the Cisco logo. Again, I have it the image stored locally. I fill the screen all white. The X and Y coordinates are a little bit different. On the X coordinates, it's a little bit less, and that's because the image is a little bit wider. And then again, we go ahead and flip that and display that, and then have a 12-second display, or a 12-second delay. And then we enter the second part of the program, which is, of course, the most important part, is really just determining where this Raspberry Pi is located, if it's in the production environment, or if it's been changed over to the OpenFlow pipeline and it is now being controlled by the Cisco Open SDN controller. So we'll go ahead and take a look at that. And it's fairly simple. What we're doing here is we have a couple variables that we're setting to 1, and I'll explain why in just a second. Have a couple IP addresses that we're going to check, and this will determine if it's in the production environment or disaster recovery. You could have a whole series of IP addresses if you wanted to. You could check. I'm just trying to make it simple, and I think once you understand how the program works, you can take that and then make it much more complex for whatever your business needs are. This is just giving a while loop to basically say keep doing it until we exit out of it. And then here what we're doing is we're using subprocess module to basically spawn another process, in this case ping, and we're telling it to ping a total of 3 times, and we want it to ping this variable prod address. And we do the same to DR status. And what the subprocess will do is it'll go ahead and it'll spawn that process, and then it'll actually return a code. And if it's successful, the return code will be 0. In the case of ping, if it sends it and doesn't receive it, it'll actually get a 2, and then if there's other errors, it'll come back as another number. But what we're really interested in is, did it return a 0 or not? So the first check we do is we basically are checking the condition. If the prod status equals 0, in other words, if it was successful, what we want to do is we want to go ahead and display a certain image on the screen. So in this case, we go ahead and display Web3, and of course we tell it what the font is. We want it in white, and that's the 255, 255, 255. We want the background to be green, and again using the RGB color coordinates, that's 0, 102, 0. And this also will go ahead and give the X and Y coordinates of the text that we want displayed. And then once we have this is all being rendered in the background, if you will. And then just like with the images, we'll go ahead, instead of using the update, we use flip, and we flip that image. And then once this is done, it'll go ahead and of course start the loop again. But if the prod status wasn't 0, then it's going to of course go down to the next one, and this is the DR status. Now if the DR status is 0, then we change a couple things. We're going to use a black text and a yellow screen. Now in the video it actually more looks like white, but technically it's yellow with the RGB coordinates. And again, the X and Y coordinates for where that text is to be displayed, and then again we flip it. Now if this still doesn't work, so it's not, if the prod IP address is not returning a 0, meaning it's successful, and the DR status IP address is not returning a 0, meaning it's not successful, we'll go ahead and then display a different image. And what we do is we display a red screen here with black text, and that way we know that at that point it's not able to ping either the production or the disaster recovery IP addresses that we're checking right here. And then this loop will continue until we break out of it. You can use a Control-C, or it's actually checking for an entry here. But that's the basics of the program. It's very simple but very powerful. You could take this, as you can imagine, and do lots of different things. And I would recommend checking into the sub process. It's a really cool way to be able to run different commands, get a result back, and then with that information you can make a decision on what you want to do in your program. So I will continue this up, and the next video that I'm going to do is on the actual Darth RASP, and in that video we'll be discussing how does that program isolate the servers, how is it able to communicate with the lights to turn them on and off, and how is it able to send text messages and emails. So I look forward to the remaining videos in the series. Thank you.